Hey, good morning. Yeah, it's my day off today. Okay, so yeah, I can drink a little bit in the morning because yeah, day off. Yeah. All right. So good morning. Um, let's formally do this. Okay, we give you some numbers and okay. Uh, so we are counting backward. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So uh, let's say there's 10. Okay. Uh, I should take some pictures before I erase this, or maybe even write it down. Okay. Yeah. I gotta find my cell phone. Ah, here. My cell phone. Okay. And my notebook. We'll do this real quick and we're gonna move on, okay? We're gonna do some economics, I mean mathematics, because it's been a while since we did mathematics, so uh, we're not gonna erase anything, alright? So, boy. Your price, alright? Get it okay and put dollar. This salary level, okay? This is salary, okay? Now, pasta price $100, $50, and $10, okay? Okay? So, this equation isn't exactly correct, by the way. Alright, so, uh, but we modify if we need. Okay, so this is a price equation, alright? I mean, population density equation. No, just yeah, population equation. Okay, so this is what's the population. This is a transactional demand, and this is a revenue. Okay, all right. Now, to do a formal integration, all right, we do it backward. Okay, it's a finite integration. Definite integration. Okay, so oh boy. From here to there, it goes like this. Okay, integrate. X is from 100, not 100. Whatever, 100 to x, okay, when price, let's say p, price p, alright? Y is 1, so 1 times dp, okay? is equal to p bar 100 to p is equal to, yeah, p minus p minus 100, right? Which is negative number, okay? So because p, if you recall, okay, let's say this is area A, okay? P is somewhere here, P, okay? So P is less than 100, okay? So we define pi over x is equal to minus a is equal to 100 minus p, okay? Is equal to minus p plus 100, okay? Well, we'll call it p, pi of p, okay? So to make this whole thing positive, okay? Why? With demand, we want to think of demand as something positive, okay? So we don't want to do negative demand, okay? So yeah, we need to flip it, all right? So what is this? With 100 here and 100 there, okay? So when x is 0, actually we're gonna rename it as x, okay? So okay, just so that it's easy for us. Now when x is 0, y is 100. When y is 0, x is 100. So it looks like a curve like this, okay? So let me see. Yeah. When x is 99, y is 1, okay? So yeah, 100, okay? Yeah, it's out of scale, but that's fine. Okay, so that's pi of x, okay? This is pi of x. So that's one integration, okay? Now, from go to here to there, so this is a pi of x. I'm sorry, this is d of x. Demand curve, okay? So I'm sorry, it's too light, right? It's very difficult for you to see. Sorry about that. Let me grab another pen. Where did all my pen go? Yeah. Okay. So What does this demand curve stand for? Yeah, it's our transactional demand. Okay, it's integration of the demographics curve. This is demographics curve according to the salary level. How many people fall in that bucket of salary level? This salary demographics. Okay. If you integrate that, it becomes transactional demand curve. Isn't that interesting? We're like combining sociology and economics right there. Okay. This is really cool stuff. This is groundbreaking, my friend. Who would have thought that, huh? I didn't. We just ran into it, okay? Oh, this is cool stuff. Of all places, Alaska. This is something really cool. Of all years 2019. Okay, so this is something cool. Yeah, you integrate demographics curve, then it becomes transition demand curve. Okay, so conceptually speaking. Okay, so let's move on. Next level. If you integrate the transactional demand curve, it becomes revenue curve. Okay. Uh, just like before, we're going from 2 to 3. Okay, demand to revenue. Just like before. Write it up there. We call it B is equal to integrate from 100 to somewhere here. We just call it X. Okay, so again from right to left. Inverse direction. Okay, so it's supposed to be negative. This curve is minus x plus 100 dx is equal to x squared minus x squared divided by 2 plus 100x bar 100x is equal to oh boy. You know, we don't want to deal with 100, okay? We don't, because it's getting too big and it's unnecessary, alright? So we call it pasta is $10, $5, and $1, okay? Because we don't want to deal with 100s, nah. Okay? No. That's just 100. I mean, 10, not 100, okay? So we don't want to deal with big numbers like that. No, it's unnecessary. It's a waste. We don't want any waste. Okay? Because it's still big. I mean, 100 divided by 2, that's what? Minus 50? Okay? And 10 times 10, 100. So, ooh, plus 50, okay? So, better. It's better than like. Alright, give me one second. And this number is supposed to be negative as well. Let's say when x is 2, okay? Actually, this one number is non-negative. How come it's non-negative? Whatever. But whatever. Conceptually, well, what is this when x is equal to 10? Minus 50. 100. Did I make any mistakes? Did I make any mistake? Minus 50, right? Okay. Yeah, integration, it's been a long time, so. Okay. Yeah, so this number, between, when x is between 0 and 10, yeah, it will be negative, right? So when it's 10, 0. Okay? Yeah, it will be negative. So yeah, we define Rx, revenue, is equal to minus b, which is equal to x squared over 2 minus 10x plus 50. Okay, so and when it's a positive parabola, right? Convex. When does it have maximization point? Yeah, let's differentiate it. Okay, so I prime x okay, so I mean minimization. When does it have minimization point? When x is equal to 10. Good, very good. So it's right here, okay? And y intersection is 50. 50 or 5? I mean, it cannot be 50. Did I make another mistake? What's the value of this when x is equal to 2? You have minus 2 plus 20. No. R of 2 is equal to what? 2 minus 20 plus 50 is equal to 32. Okay, it grows pretty fast. Alright, so okay, how about intersection between this parabola and the demand? What's the intersection? Well, let's find it out. Uh, my goodness. You have x squared to minus. You equalize these two things, okay? So minus 9x plus 40 equals 0. So x squared minus 18x plus 80 is equal to 0. Yeah, 8, 10, minus minus, right? Okay, so 8. Okay, so that's the intersection, okay. So let's say there's 8 here somewhere. 8. Yeah, it's a very fast growing kind of parabola. Okay. So here you have what? 50. Okay, again, it's not to the scale, but yeah, it should be like convex like that. Okay, parabola. Sorry about not being a good drawer, but good drawing here. We are doing mathematics. Okay, we are not doing arts. So yeah, it's kind of beside the point. I love fine art. Okay, because I used to be very good at drawing in my middle school, high school days, and also some college days too. I drew on my own acrylic painting. I love doing that stuff. Okay, so also with pencils and stuff. Yeah, I was very good at it. Watercolor, I wasn't very good at it. Okay, because that was very tricky. Okay, so, all right. Yeah, acrylic painting they use synthetic kind of plastic based paints, but it kind of imitates oil painting. But acrylic color you can use it with water. Oil painting, yeah, that's I've never done it. Okay, but acrylic painting is kind of similar to that. So texture wise, it dries faster too. Okay, so yeah, great invention. I don't know who invented that, but I'm guessing it's probably America. Okay, because all great, most of great modern invention came from America. Okay, so mighty proud, mighty proud. Okay, so our next assignment will be make this salary demographics curve to be linear. Then demand curve will be parabolic, second order polynomial, and then revenue curve will third order polynomial. Okay, so that will be our next step, and then from there we can kind of demonstrate that Sam Walton principle can be true. Okay, the next step for you would be find some necessary and sufficient condition when Sam Walton principle is true, or maybe it's always true. Then you make it into a theorem and you prove it. You call it Sam Walton theorem. Okay, but we are not gonna go there. Okay, we did enough. So I'm gonna write this down, and because we'll get back to mathematics. Why? Because we've done enough economics and we are fed up with it. We're sick and tired of it. Okay, so I am. I need some break from economics. Okay, we'll get back to this later. All right. So now after break we'll do some mathematics. Okay. What mathematics? Prime number function. Well, before that, prime number counting function. We find fixed form formula for that, closed form formula. Okay. We already did actually. Okay, but we didn't quite elaborate on it. So we'll revisit. As we revisit things, we get better and better, right? So, yeah. I gotta draw this. Yeah. I'm gonna take a break, okay? Yeah, because economists they're not very good at mathematics, so we as mathematicians, it's so easy to defeat them. I mean, if we also know I mean, economics. Yeah, I'm sorry to be so arrogant, but you don't want to censor yourself too much based on some sympathy or political correctness. You do not want that, okay? Because then you are missing out a lot of truth and knowledge. So don't be too politically correct and don't care too much about other people's feelings, because you are missing out or the other half of the truth, knowledge, inconvenient truth, or whatever. Okay, it's a good term. Well, ex Vice President Al Gore, inconvenient truth. Yeah, it's very cool term. Yeah, I appreciate that. So much to write, dude. Oh boy. Forgot to erase 1 0 here. Yeah, writing all this down in this way, it's kind of like religious ritual. Yeah, we mathematicians, we obey this mathematical formula like religiously. Mathematics is an ideology, and yeah, religion is also an ideology. Okay, so in humanology we call it concept. All right, ideologies, isms. Yeah, religion and politics. It's just they just happen to be one of ideologies, like mathematics. Okay, that's why they look similar because they are all ideologies. They're instances of ideology. What is ideology? Like concept, it's something some people live for. Ideology is one level higher than human beings. We are their food. Ideology is kind of like God, one level higher than us. So we work for ideologies that we subscribe to, the ideology that possesses us, enslave us, subjugate us. So yeah, but once you know that, then you take advantage of ideologies like politicians and business people. Okay, so you become a higher animal. All right. Am I speaking all what Hebrew and Greeks to you? All right. I mean, if you have watched this episode, yeah, you probably understand what I'm saying. But fruit fly, man. I have to kill that thing. Okay. I killed it. I killed it. Okay, I used this notebook and this big TV screen. I finally killed it. Fruit fly is dead. Ah. No harm done to the television. Actually made it a little bit cleaner. Just one patch. Now, where in my notebook did that fruit fly hit? Maybe here. I just wiped it off anywhere just to make myself feel better. Kind of like cat washing their face with their saliva, kind of. You have no idea what I'm saying, right? Unless you are Korean. It's Korean expression, okay. You're not quite washing your face very well, but you're just wash just a little bit, okay, with water, okay. So yeah, just to make you feel better, kind of pretend, pretending, kind of, you know, like when you vacuum the floor, you don't go all the way like in the corner. You just do it a little bit, right? Just to make yourself feel better, right? But not very effective, thorough cleaning. That's what I meant. Okay, so yeah, we are done with economics now because I wrote it down. All right, so that's it. Uh, Maybe this. Okay, so real quick. All right, that enough is enough. So we're done with economics for now. Okay, so and what we're gonna do is we do mathematics. So after break, we go back to the prime counting function. Okay, so yeah. Why? We kind of miss it, don't you? I mean, I do. I do miss mathematics. It's been a while, so we'll do that. Okay, take 5. I have to apologize. I made an error. Ah, I realized an error here. I realized an error here. Okay, so we have to correct it. So no mathematics yet. I mean, this is economical mathematics, so still mathematics, but uh, revenue is not this. It's not integration. Okay, what is this integration? I don't know what the hell this is. Maybe it has some meaning, okay, but it's not revenue. We'll call it just R, big R, okay. I don't know what this means, but it's not revenue. For revenue, we'll use small r, okay. Hey, I'm sorry. Maybe it has some meaning, but I don't know and I don't care. Not now. Okay, so going back to the drawing board. We're not going to erase this, okay, but we'll do revenue equation with small r, alright? Real quick, because I am very eager to do mathematics, okay, so let me take a picture of this. No matter what it means, well, we worked it out, so we don't want to quite scrap it. scrap it, right? Can look nice exercise, but it's not revenue. Okay. What is revenue? Yeah, we'll do it. Okay, so multiply by x. Okay, so it's a lot easier than integration actually. A lot easier. Alright, so let's erase this. Yeah, sorry about the goof up. But hey, it happens, right? It happens. Boy. Okay. Something funny that happened in my workplace, sometimes we have some formal meeting with some other people. So I always have blazer, sport coat, suit. Do I have dress shirts and tie? Yeah, I always carry dress shirt and tie just in case, and also necktie uh, clip as well. Okay, in my car because you never know. Maybe I need it. So nobody else had that except for me. So okay, then my boss is telling me, yeah, you go to that meeting. So okay, all right, let's do this. I wanna switch my glasses, by the way. This glass is too formal. I'm at home. It's my holiday. There you go. Okay. So we already have demand curve equation, right? You have 10, 10, hang 10, 10, 10. You have demand curve, okay? Dx is minus x plus 10, right? And what's the revenue? Rx is minus x squared plus 10x, okay? It's just dx times x. This. And by middle point theorem, profit maximization happens in the middle. You just, what is that? R prime x is equal to minus 2x plus 10, right? When it's 0, yeah, x is 5. That's profit maximization point. Yeah, it's that simple because we corrected our error. Alright, so let me write this down. What does big R mean? Economically speaking, I don't know, and I don't have time for it now. Okay, why don't you figure it out? I don't have time, alright? So well, we need at least we need to draw this curve, right? Okay. Uh, yeah, we'll do a couple of more things here, and then we are going to really move out of this. Okay. We are so eager to get back to mathematics. Okay, but not now. I mean, not yet. Well, first you need to draw some diagram. This parabola, it go through 0 and 10, right? And yeah, different color. Something like this. Okay, so this is the revenue curve. Okay, so this is R of X. Okay, so let me draw that in my notebook. That's it. Okay. There's nothing to it really. When X is 5, hey, is this right? When X is 5, R of 5 is minus 25 plus 50 is 25? That doesn't sound right. Where did I err again? Never ending story, man. Oh my goodness. I guess I drew this curve wrong somehow. I don't know. Let's find intersection between these two curves, okay? So, real quick. So, x squared minus 11x plus 10 is equal to 0. So, 10, 1, minus, minus. So, x is equal to 1 and 10. Really? Okay, well, whatever. So, my goodness, I have to redraw this curve. Okay. Again, my calculus sucks. Okay, it's been a long time. So when x is 1, 9, 9. Okay. So it's a steeper curve. Okay, so here, I'll draw this in green. Let's just pretend this guy is 25, okay? 25 right here. So the curve will look like a rocket, okay? So 25, 5. Here you have what? Again, it's not to the scale, okay? 1, 9, okay? You have 10, 0. I have to erase this and redraw it. Pain in the ass, dude. whatever. So yeah, profit maximization happen in the middle. Okay, so and we'll stop here in terms of economics. Okay, because we are eager to get back to number theory in mathematics. Okay, we dealt enough with the calculus. Now we're gonna do this continuous calculus. I mean continuous mathematics, calculus. Discrete mathematics is like discontinuous mathematics. Okay, it's like stepwise, like number one, two, three, nothing in between. It's number theory, right? All right. So, without further ado, we'll continue charging on. We'll go back to mathematics. Okay, so and we're gonna use this board. We'll take a break very shortly, all right? It's very pretty coloring, so let me take a picture of this to kind of memorialize this picture here, this scene. Yeah, good enough. I bet I took a picture of this before, so. Okay. We just lay out the foundation, okay, for the prime counting function, okay, and then we take a break and then we'll get back to it, okay. You know, I kind of like those pens back there, because these pens are there too weak. These pens are no good. Okay, it's too light. Let's take a break now, okay? So then we'll get back. Take 5. Okay. I'm gonna drink vodka just a little bit because yeah, I'm not going to work. Just my esophagus needs some time to healing. Yeah, because I'm really excited about this. So yeah, this fixed form, closed form formula for counting function, it prime counting function, it has some significance, theoretically at least. Practically, I don't know. Maybe it's too inefficient an algorithm. It's based on Eratosthenes' sieve, uh, but at least theoretically it has some importance. Okay, so there's some great interest in this area. Practically, I don't know. Maybe this is very inefficient way of encoding Eratosthenes' sieve algorithm. Okay, well, whatever. It could be useful just because it's fixed form formula, and to find a very big prime number, yeah, it could be useful. Okay, so I don't know. We are just curious. Okay, that's why we are doing it. Okay. Yeah. So we'll keep doing it. Okay. So prime counting function. Okay, some mathematician came up with it. Possibly Euler or Gauss. Euler is what Switzerland. I thought he was German, but I learned that he's Switzerland national. Did he live in like Russia or something? I don't know. Yeah, Gauss, Euler, whoever, right? So yeah, prime counting function is given a number, like let's say number 7. How many prime numbers are there? 7 or less, between 2 and 7. Okay, so inclusive. That's the definition of prime counting function. Okay, so grab my pens. Yeah, so we'll get back to that. What I'm gonna show you, you may say, "Oh, what's the point of doing all this? You're so stupid. Your function sucks. Your math sucks ass." Yeah, call all the names you want because we'll do it very roundabout way. It's like prove 1 plus 1 is equal to 2 using calculus or whatever. What's the point of doing all this? Because yeah, small numbers. Like we're gonna make an example of 7. All right, in small numbers, yeah, it's very. It seems unnecessarily complex way of counting prime numbers less than 7. But when we deal with big prime numbers, what's the biggest prime numbers I know of? Is 97 a prime number? 97? I don't know. Okay, I have no. How about 113? Is that prime number? Again, I don't know. Yeah, so it can be useful, perhaps if even efficient. We're finding very big prime numbers. Okay, so let's enough introduction. Okay, let's just go ahead and do it. All right, so you have natural number set n top 7 is equal to, okay, now we have multiple set, and 2 top 7 is all the multiples of 2, each of which is 7 or less. Okay, so we have 2, 4, 6. We don't do comma, and we don't do squiggly, this curly bracket. We don't do that. Okay, it's so unnecessary. All right. Give me 1 second. Just Yahoo Mail advertisement. I get that a lot. But there's so many. I used to like block them one by one, filter them out. But I stopped doing that because there's just too many advertisers. So nowadays, I kind of enjoy watching their advertisement in the bathroom. Yeah, diverse businesses struggling to survive. So yeah, I can appreciate that. Now, M3 top 7, 3, 6. That's it. And we stop there. Why? Because, well, let's just for the sake of argument. No, not for the sake of argument, but for the sake of illustration, we'll just do one more, okay? Now, mu set, that's why we call this mu algebra, okay? Is proper set, okay? So mu 2 top 7 is equal to 4 and 6 because you subtract 2. You get rid of the beginning element. Now, mu 3 top 7 is equal to 6. Mu 4 top 7 is equal to empty set. 5, okay? That's why we don't need 4 and more, okay? Because 4 times 2 is 8. That's over 7, so it doesn't belong in this set, okay? So, okay? So prime function, prime set, we know prime set of primes, each of whose member is okay, prime set, it's P top 7 is a prime set, okay? P is set of all primes. Yeah, P top infinity, okay? So x is prime, x is positive integer, and x is between 2 and 7, okay? So in general, yeah, we can call this 7t, top, upper limit, okay? So, yeah. Okay? What is this? Well, it's this, my friend. It's this formula, I mean, this example is very handy dandy and very easy. All right, so it's this. Okay, so P7, my friend, watch, N7 minus well, let's just spell it out. What are all the primes, each of which is less? Okay, funny English sentence. Okay, P top 7 is a set of primes, each of which is less than or equal to 7. All right, so it's kind of, I'm trying to come up with this beautiful sentence. It passed through my head, then I forgot. Like, it's a set each of whose members are less than 7, something like that. Each of whose members. It's a set each of whose members is 7 or less. Okay. P top 7 is a set each of whose members is 7 or less. Something like that. Okay. Yeah, we have 2, 3, 5, 7, right? 2, 3, 5, 7. Okay. So all we gotta get rid of, and this is what? Let's make some room, shall we? I'm very excited now. Okay. Now, what is 4 and 6 in this example? Set 4 and 6. They are composite numbers, right? We will label this, okay? Set of all the composite numbers under 7, okay? Under 7 meaning less than or equal to, okay? So that's what this guy is. Composite. C top 7, okay? So we gotta get rid of all the composites, and then what's left is our prime number set. Okay, so basically what we are saying is P top 7 is N top 7 minus C top 7. Okay? Yeah, I mean, you may laugh at me if you know a lot of mathematics. Oh, that's so easy. But yeah, so what? Easy stuff, that's all I know. I don't know any group theory. I don't know any abstract algebra. I know just a little, okay? But, yeah. So how do we find all the numbers, composite numbers? Oh yeah, this, mu algebra, okay, so, so in this particular example, is this. Mu2 top 7 union mu3 top 7. Okay. In this particular example. And we're gonna generalize this later, but we were in the past we are too wrapped up in generalization. We'll do that later, okay? So now let's get down to earth and make some concrete examples, alright? So I'm drinking this fungus pollen. It's not pollen. How do you call those tiny little fungus seeds? I forgot what it's called. Okay, so yeah, maybe in my belly, maybe they will start to grow this fungus. Become you pop me up, I become a human puffball mushroom and like alien. You know, it pops in my belly because I have so much. Just kidding. Mushroom vodka joke. How about that? Mm. Okay, so mathematicians like Euler, Gauss, or whoever way back in what 1700s, 1800s, yeah, they realized prime counting function is a lot easier to calculate than prime number function, the actual prime number function. We'll get to that, okay? But yeah, that's because they realize prime number is very intractable problem. It's very difficult, unwieldy kind of intractable, wild animal. You know, you try to tame this horse, wild horse. That's not easy, right? Yeah, prime numbers like this are natural. You know, it's a wild animal. So yeah, it's very to find a formula for this prime number is like taming this wild animal. Okay, and they kind of try to go in an indirect way, and that's prime number counting function, pi. Okay, it's a lot easier, but still they didn't have fixed closed form formula for it. They have some asymptotic approximation like logarithmic, which is extremely smart. Like they use what Fibonacci sequence. Oh, yeah, I did read some about that. I don't 100% like I cannot recite it, but I did understand what they were saying. Okay, very smart, very smart. Okay, all these smart mathematicians. Oh, they're good. Okay, so I was impressed. It was beautifully done by this French mathematician, something Lame, Lame. It's not lame. Lame, Lame, Lame theorem, and a lot of other mathematicians. They learn from other people, and yeah, they figured it out. Okay, yeah, I did read about it. Okay, because I mean, the kind of main subject here. So, but we here we are different. We are different. Okay, we are approaching this prime number problem from a radically different angle. Set theory. Yeah, Mr. Herr, Herr, Gerug, Cantor, Cantor. he's German, so Georg, Georg, Kantor. It's been a long time since I studied German. Okay, so yeah, please laugh at me. I'm happy to entertain you. You know, when I go to Walmart, right? Yeah, some young kids they laugh at me. Oh, look at him! He's so funny. He looks so funny. Look at his eyes. I'm happy to entertain children, anyone. Okay. Yeah. Oh, yeah. Comedian like self-deprecative jokes, class clown. You know. Sure. Yeah, I'm happy to entertain kids or anyone. You of all people. Yeah, I'm happy to entertain you. Okay. Is it time to take a break yet? I don't know. So yeah, we'll start counting because it's easier. And also, yeah, the absolute value or n open close paren, yeah, the number of members in this set, yeah, there will be our prime counting function. There's another fruit fly. They're after my vodka, dude. You remember that Mr. Bean? There's this fly. He went to a park and he has this cherry topped cupcake as a dessert. It's flying this full blown fly. It's not fruit fly. But in my house, fruit flies because if there's this full blown big fly, oh, that's easy to kill. But fruit fly, what happens is I grab it right when it's flying, then I start to squish it, and it flies away because it's so tiny. How do I kill a fly? I use my notebook. Sacrilegious? Oh, this notebook I can burn it. Okay, it doesn't mean anything. It's not like Bible. Would I kill a fruit fly with the Bible or Quran, Confucius, Lao Tzu, Confucius, whatever, Upanishad? Yes. Why? Because I don't idolize those books. Okay, I'm an iconoclast. We humanologists, we are against idolatry. If I have a constitution book, would I kill fruit fly with it? I mean, regular fly with it? Yes. Just book. I, it's mine. It's my chattel. So I don't idolize things. Okay, so I know Muslims. Yeah, they tend to treat this Quran book very holy manner, which I appreciate. I do, but okay, just for the respect for Muslims, because I have many Muslim friends. Okay, I'm not going to use Quran to kill these flies. Okay, I use Bible. How about that? Ah! Oh, there's a fly. I have to pick a book to kill that fly with. Quran? No, no, I don't want to offend them. Okay, so how about Bible? Yeah, let's pick Bible. How about calculus book? How about physics book? Confucius, Lao Tzu, Upanishad. Yeah, sure. I'm bad. Oh boy. Let's take 5 minutes break, okay, before somebody kills me. I'm horrible. Take five, okay? So we get back to this, alright? I'm bad. I don't even deny it. Well, let me grab my phone and my glasses with me because sometimes I take pictures of the landscape or words or whatever. All right. So, we're gonna have to switch out the whiteboard, okay? So, yeah. We're done with the economics for now, so yeah, just erase this. Let's grab an eraser. Two kinds of my favorite whiteboards, okay? So, heavy one, this, and the black and white one. It's beautiful. Yeah. My toe is giving me some trouble. This corner of my toe sometimes it get infected. I mean, I wash every day, but sometimes this one corner of my left toe, thumb toe. Let me wash my hands. So what I do, yeah, I learned. Yeah, you just turn on hot water, but not too hot. You don't want to burn your toe. Yeah, just let it flow. Hot water, as hot as you can tolerate. Yeah, for 5 minutes. Then all the blood comes there because it's so hot. Yeah, then you fight off this fungus or bacteria, whatever, right? Yeah, then it gets better. Fungus. Good fungus, bad fungus. Good bacteria, bad bacteria. Maybe they're same kind. I don't know. whatever. Okay. So now we are doing prime counting function. Okay, so let's just we have prime number set p. Okay. Uh, pi x is equal to absolute value of p top x. Okay. Yeah. Set of all primes, each of which is x or less. Okay. We don't care about 1 or 0 or negative numbers. The n set n top x is top from 2 and above. All positive integers, 2 or more. Okay. Because we don't care about 1 or 0 or negative integers. Okay, so prime numbers, yeah, it's purely natural number. Okay, so it's number theory. All right, so it's very compact way of expressing this equation. You have to love this. Okay, yeah, it's definitional. All right, so you got I think this is really cool. You gotta love this equation. All right, so I'm drinking too much. But it's my holiday. Okay, it's my day off. So I will leave to do this. All right. Now, uh, let's say M2 top 7 absolute value is what? What is the absolute value of a set? Yeah, number of members in this set. Just for you, okay? Yeah, it's a floor function, right? Floor function. But we rather use this Q quotient. 7 quotient 2. It's a Euclidean division, right? You divide 7 by 2, what's the quotient? 3. What's the remainder? 1. Okay. It's a lot easier than this floor function 7 divided by 2. No. 7q2 is more compact, more efficient symbol notational convention. Okay, so we stick with this. Okay. Yeah, this you have maybe this floor function, ceiling function, and then you also have something like this Gaussian symbol. Right? Gaussian symbol is the nearest integer. I think that's what I remember. I learned about this when I was in high school in South Korea. So, okay. Yeah, Gaussian symbol. Maybe it's 4. The nearest integer. I think. Okay, so but floor function is you're rounding it down. Ceiling function, you're rounding it up. Okay. Okay. Gaussian function, that's more like a combination of floor function and ceiling function. The nearest integer. That's what I recall. Okay, so which is very cool. Okay, it's a systematic, very Gaussian, which is very smart mathematician. Gauss, Carl Friedrich Gauss. Yeah, he's cool. Great physicist as well. What Euler, Leonard Euler? He's more pure mathematician, right? But Gauss, yeah, he's good physicist as well. Okay, so all right, so enough of that. Okay, now how about mu? Mu to top 7. What is mu? Is this m to 7 n to top 7 minus 2 is equal to m. I'm spelling this out so that we can generalize easier, okay? Okay? Yeah, it's a proper set, kind of. You just subtract this divisor, alright? We just count pure multiples. Yeah, 2 times 1, forget it, okay? Pure composites, okay? So, yeah, that's what it is. Okay? Yeah. Okay. So, we have up here P7 absolute value is equal to uh, absolute value of n top 7 minus c top 7, right? Now, it kind of reminds us of this in group theory homomorphism, okay? So, but we don't have to go there because I don't think it's necessary to know too much about homomorphism, okay? So, we just want to know, is this same as, can we distribute it? Can we split this? We put question mark here. Can we split this? Can we can we distribute this absolute value operator? Can we distribute it? Can we split this? Is this correct? What's necessary and sufficient condition that allows us to do this splitting, like in group theory homomorphism? I'm because something I learned quite recently, okay, and maybe some of you know group theory, okay, so I just want to please you, entertain you by finding some common denominator between you and me, okay, so that you get perhaps a little bit more interest in this, okay, so inviting, encouraging, okay, so to find some mutual ground, something in common between you and me, okay, if you happen to know group theory. If you do, probably you do more than I do, okay, because I don't know too much about it, okay. In this instance, it is true. Okay, why? Because C, C top 7 is a subset of N top 7. Okay, that's why this is true. Answer is yes. Because C is a subset of N. Yeah, it could be the same, or proper subset, whatever. Okay. Alright. So, we know N top 7 is 7 minus 1 is 6. Why? Because, yeah, what is N top 7? From 2 to 7, positive integers. We exclude 1. So that's why we subtract 1. Okay, we know that. Okay, now, how about absolute value of C top 7? What are all the, what is the number of members of all the composite numbers under 7? Under 7 means 7 or less. Okay? Yeah, it's this. It's C top 7, okay, is, yeah, mu 2 union mu 3. Okay? I mean, you can say union mu 4 union mu 5 union mu 6 union mu 7, but from here on they will empty set because mu is a proper set. Okay, multiples of 4s like 4, 8, 12, but it has to be under, yeah, I'm sorry, 7, top 7. Okay, but you subtract multiple set with in the divisor, so they become all empty, 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 empty. Okay, so yeah, you only need to go up to 3, 7 quotient 2. Okay, so you can stop there. Okay, because 4 times 2, that's 8. It's beyond the limit. So okay, all right, that's that. What time is it? Let's take a break. Okay, so we may continue or we may stop. Okay, so yeah, whatever. Take 5, okay? Feel free to mule on this. Yeah, feel free to think about this. Okay, we're back. Uh, all right. We're gonna have to switch out this whiteboard again. Okay, so I gave you enough time to stare at it. So, yeah. Okay. Okay. What are these things? I mean, this sticky thing with magnet. Yeah, it's from the back of some pen, I guess. Where are my pens? Yeah. I have so many pens hanging around. Where's my eraser? Back there. Good. Okay. Yeah, we'll take it out. Adopt it as our pet magnet. Whatever. Another pet magnet right here. Okay. So this feral cat, I guess they do deserve some appreciation because they killed the mice, and I saw a small mouse, Alaskan mouse, they call it shrew, uh, in my yard, and I don't want any mouse in my premises. So yeah, cats, yeah, they kill those mouse. So yeah, I guess that maybe it's worthwhile to clean after them. Yeah, sure. They're doing their job, killing all these mice. You know, cats. Yeah, sometimes I heard the story. They kill a mouse and drop you in front of your door to thank you, right? I hope they don't do that, okay? Because I don't want any dead mouse in front of my door. I would appreciate them cats, them cats killing mice for me, okay? Because I don't want any mice. And they're cute, but no, they're vermins. Okay, so whatever. All right. So, what we're not gonna do very long, okay? We'll just do 20 more minutes, okay? Then we call it a day, right? So, yeah, this blue is strong enough. So, okay, okay. What's that? I mean, it's traditional, that theory, right? Yeah, it's no longer union, my friend. It's plus. So this counting over set, okay? There's a bridge between set theory and algebra. All right. Intersection. Dido, Dido, minus. This is why we spend so much time in Euclidean algebra, okay? Euclidean algorithm. It's LCM, okay? 2 and 3 multiples of 2, LCM, okay? So 2 LCM 3, least common multiple, okay? Well, let's just spell it out. Okay. So, legwork. Yeah, manual job. It does cleanse our souls. Some lesson my friend told me. What's this? Well, let's first do this. M to top 7, absolute value thereof is how many multiples of 2, including 2, are there, each of which is 7 or less? 3. Okay, so that's a 7 quotient 2. Okay. Okay, how about mu? 7 quotient 2 minus 1. Okay, so yeah, we can convert that all into this quotient Q algebra. Okay, 7 quotient 2 minus 1 plus 7 quotient 3 minus 1 okay, minus, yeah, what's the least common multiple of 2 and 3? 6. Okay, so 7 quotient 6 minus 1. Okay, what's that? 3 minus 1 plus 2 minus 1 minus 1 minus 1. Okay, what's that? 2 plus 1 is equal to 3. But it's supposed to be 2. Okay, but composites, they're only 4 and 6. Pure composites, they're only 4 and 6. Maybe I erred somewhere. Oh my goodness. It's kind of deja vu for me. So I feel like I've done this before. Deja vu. So this mu2 is like 2, 4, 6. I don't know, 4 and 6. Okay, and mu3 is just 6, right? We want this to be 1, not 0. Okay, so I think we have to distinguish big C and small c. Okay, so maybe. Or not. C is a pure composite. Okay, it's not two or three. No, it has to be four, six, or six. All right, so okay, we are maybe jumping around, getting ahead of ourselves. So 4,6, right? Hmm. Something like that. I'm struggling. This is not easy. From this guy, I'm sorry, I better use different color. From this guy to this guy, I don't know yet. Alright, so. Where this cap for my pen? Where did I put it? Ah, it's magnetic, so it should be somewhere. You know, why don't we take a break, okay? So, I gotta find the cap for this pen. You know, I don't know where it is. I may have to discard this pen because I lost a cap, or maybe I will steal from some other stupid pen. Man. hang it. I don't know where I put this cap. Okay, so where is this cap to my pen? Ah. You know, we don't want to spend any more time on this, so I'm gonna discard this pen, okay? So, yeah, call it a genocide, whatever, killing of the innocent. It's just a pen, okay? So I have to discard this, okay? So let's take 5 minutes break, okay? So we don't want to waste any more time on this. Okay, we are off by one. All right. I think the key is between these two things: intersection and LCM, least common multiple. All right. Maybe there's plus one or minus one. Okay, we are off by one. We'll have to figure this out with multiple other whiteboards. Okay, we will correct this error. Okay. Yeah, because right now I'm too drunk. Okay, so I'm hungry. So it's my day off. So we'll get this done maybe later this evening or tomorrow. Okay, so yeah, it's just we are off by one. Okay, so it's quite not quite adding up. All right, so if this is all Greeks and Hebrew to you, Chinese to you, Japanese to you, don't worry. Okay, we'll be back this evening or tomorrow. Okay, I gotta eat. All right. All right. Thank you. Okay. Bye.